And if you just want sleep, hello everyone, welcome back. For lesson 5, we're going to talk about decision making. And to start off this lesson, we're going to look at this diagram here. So the joke is that when you go off to college or university, within this diagram of a triangle, you can only pick 2 out of the 3 options, right? So the 3 options are social life, good grades, and enough sleep. And the joke is that you can't have it all. You can't have it all and balance the sand. It's, I guess, a sane life, right? You can only have 2. Like if you want good grades and social life, you got to sacrifice your sleep, right? If you want to have good grades and sleep well, you can't have a social life. And if you just want sleep and social life, well, then your grades gonna suffer. Like you're not gonna study, and it kind of makes sense. But as a student in college or university, this is the type of decisions that you would make. And when we talk about decisions, there's also stuff like decision trees. I don't know how correct this tree is, but we could make a binary decision tree where if something is able to fly, if it's true, and we can ask, does it lay eggs? If it's true, then we can consider that as a bird. If it doesn't lay eggs, it's a mammal. On the other side, if it doesn't fly, but has feathers, it could be a bird because it has feathers. But if it doesn't fly and doesn't have feathers, we can kind of safely assume that it is a mammal. And decision making is fun. It's fun for programming because we get to create multiple pathways. Most often, programming is linear, but when we do complex scenario or when we handle complex scenario, a program should be able to make decision based on either branching or looping. Okay. And for us to do branching or looping, we use comparison of values or logic or Boolean logic to help us. So our tools are comparison operators, Boolean logical operators, conditional statements, and while loop. So let's talk about branching. So if we can create a single branch, that's called an if statement, we can have a program execute a special block of code if only a certain condition is true. And in this scenario, if the condition wasn't true, the program will just continue on and skip that block of code and go on to the next. So an example would be, if I'm sad, I am going to eat pizza. I am going to do homework. So in this scenario here, it sounds like I'm going to do homework no matter what, but we have a condition. We have a condition where I can eat pizza, and that condition is me being sad is true. So it says, if I am sad, I'm going to eat pizza. And no matter what, I am going to do homework in this scenario. Now, that wasn't fun. That was just a single branch. Like, I only have one scenario to eat pizza. We can create 2 branches by creating something called an if-else statement. We can have a program execute a special block if a condition is true. We can also have a program execute a special block that is different from the first one if that condition we checked was false. Okay. And when either branch is finished with its code, the program will continue on with this code until the end. It says here, if I'm sad, I'm going to eat pizza. Else, or you can use the word otherwise, I am going to eat a salad. And no matter what, once again, I am going to do homework after all this. Okay, so I eat pizza if I'm sad here, but if I'm not sad, apparently I want to be healthy and I'm going to eat a salad. So we had binary pathways for a program, and after any of our pathway was done, we got to do homework afterwards. Now, we can also have multiple but related branches. So this one's a little tricky. We're creating related branches. The conditions must be related, and the condition must be tested only, the new conditions, if the previous condition evaluated to false. And then for all these, an else statement is never really required, but it will only be executed if all the conditions that were connected to it evaluated to false. So let's see another example. If I am sad, I'm going to eat pizza. Else if I am feeling skinny, I'm going to eat a salad to keep that feeling of being skinny. Else if I am feeling daring, I'm going to eat a spicy ramen. Right? And after all this is done, right, no matter which pathway I went to, I can still write, or I can still do my homework. I'm going to do my homework. So in this here, I have three options. If I'm sad, I'm eating pizza. If I feel skinny, I'm going to eat a salad. If I'm feeling a little daring, I'm going to eat spicy ramen. We have created now multiple pathways to put some more color into our program. Then we can have nested branches, where our branches have their own branches, so we're adding on complexity. As a programmer, you don't want to go more than three levels deep, but for now, we're allowed to do whatever we want, and this is called nesting. So we can have one condition that says if I'm sad, and when I'm sad, I can go into a decision tree almost, right? If I'm sad, if there's pizza, I'll eat a pizza. Else, if there's a salad, I'll eat that salad. And if all of that was false, I have an else within that nested condition where I'll just go see therapy. Like that is the thing. I don't have pizza, I don't have salad, I have no food. So basically, I'll go see therapy. And that's how this would simplify. Then we have, aside from branching, a concept of looping, ability to repeat a block of code over and over again. And for this one, we're going to talk about a concept called a while loop. A while loop works as follows. A while loop starts and it looks at a condition. As long as a condition is true, it executes this block of code. And then after it's finished, it rechecks that condition at the top. If it's still true, it repeats the code again. It repeats the block of code that it belongs to. And then when that is done, it goes back up to the top where the condition started, rechecks the condition, and it goes over again if it was still true. And once the tolerance is false, it will continue on with the program. So that's how a while loop works. It's like an if statement where it gets to repeat its block of code as long as the condition stays true. As soon as that condition turns false after the block of code was executed, then can you continue on with the program. And there is a term where a while loop that never terminates or ends, and that's called a infinite while loop. So in this situation here, it says while the light is red, the pedestrians are not allowed to cross the street. So in this situation here, we're in a loop. As long as the light is red, the pedestrians that are walking on the streets are not allowed to cross the street at the moment. Okay? And as soon as that statement, that condition statement of the light being red is false, the pedestrians should be allowed to cross the street. All right. To create these type of conditions in programming as well, we can create comparison operators, right? Something to be true or false, that's a condition. And we can compare values to say that, hey, this is true or this is false. So, for example, we can compare if two values are equal to each other or not equal to each other. We use a double equal sign for equal to, and not equal to is denoted by exclamation equal sign. So in this example here, variable num1 is equal to 42 and num2 is equal to 6. Right? If I were to ask Python, hey, is num1 equal to num2 or equivalent to num2, it's going to output false when I run that operation. It has created a condition that these two variable values are not equal to each other. And if I were to ask, hey, is num1 not equal to num2, it's going to output and calculate this true-false calculation to be true. We can check for greater than or greater or equal to, not greater than, that's impossible. We're looking for greater or equal to, we have those operators. We also have a less or equal to operator to use when we compare two values. These are called binary comparison operators because they compare two values, left operand and the right operand, and they will always produce a Boolean value of true or false. Then we have logical operators, and there are three logical operators called and or not. These are not operators that allows us to create a collection. They don't allow us to combine values, but rather they analyze the conditions that are on each side of the operator and simplifies it to either a value true or false. So the AND operator, both conditions of the left condition and the right condition of the AND operator must be true, both of them, for the entire statement to simplify to true. Whereas an OR logical operator, either the left one has to be true, or the right side has to be true, or even both of them being true will simplify the entire statement to be true. And then there's the not operator. It's pretty much the reversal operator. It converts a true situation into false and converts a false situation into true in a overall simplified setting. So here's an example. If there are no taxis, and the train is late to the station, Mr. Park is late to work. That means if both of those statements of left and right of the and is true, am I late? As long as one of those statements is false, I won't be late to work. Next, if there's Nutella in the cupboard or there's a bag of chips, Mr. Park is snacking at nighttime. Okay. As long as one of the statements are true, or even both of the statement of there being Nutella in the cupboards or a bag of chips, I get to snack at nighttime. Thirdly, if the Pokemon card store is not open, Mr. Park wasted his car gas to get to the store that day, right? This means that I could have said if the Pokemon card store is closed, but we can also use a not operator to reverse something that is either true or false. Right. So today on this lesson, we talked about decision making, how we can have branches and loops to create decisions throughout our program. And we use comparison operators to compare two values. And we also use logical operators to combine two true false statements and to help us simplify them into a single value of true or false. And as always, thank you so much for watching and stay classy.